The Nessus scanner can be used to do vulnerability assessment on network-connected hosts. To use Nessus, it first needs to be installed. Installation instructions, download of the packages, and the license key are available from the Nessus website. There is a license key for home users to practice with Nessus. It does have some restricted functionality, such as not all scan templates are available, and you can only scan local subnets, and I believe you can't scan more than a Class C subnet. But the home license is plenty enough to practice with. Once Nessus is installed, you need to start the Nessus service. If you're using an operating system like Samurai, the one we're using now, when you log in, you're going to be logged in as a regular user. So you'll either need to escalate privileges to root, or you'll need to start Nessus with the sudo command to run Nessus as root. If you're on an operating system such as Kali Linux, where the default user is the root user, then this step may not be necessary. So to start, we'll go ahead and get the Nessus daemon running. So on this operating system, we've already got the Nessus daemon scheduled to start at startup, and we can see that the process is running on 1134. You want to verify connectivity to the target. Typically, when you're doing a Nessus assessment, you're either going to discover the targets using Nessus, or you're going to feed information from a tool like Nmap into Nessus. The Nmap XML files can be uploaded into Nessus. Also, you can just copy the IP addresses of the targets out of Nmap. In this case, we're going to be using the Metasploitable framework as the target. Metasploitable is a vulnerable operating system that's distributed as a virtual machine by Rapid7. So we already have Metasploitable running. Also note that you need to make sure that the host that has Nessus running has connectivity to the Metasploitable framework. In this case, we have both virtual machines running inside of VMware. I've configured a network card in each of the virtual machines to be on a host-only network. That's a network that's only available to this host. The host itself, in this case a Mac, is available on this network as well, but we're going to ignore the Mac. The IP address on which the Metasploitable is running is 172.16.0.162. If you're using VMware and you're setting up host-only networks, you'll notice that the host-only networks start with 172.16.0, and then are assigned a random number as the last octet, in this case 162 for Metasploitable. We need to verify that the Samurai Linux installation is also on the host-only network. Samurai has two network cards associated with it. One of them is a NAT running at 10.0.0.2.40. That's not the network we're going to use to do the scan. The host-only network is 172.16.0.189. And again, the host-only networks will start with 172.16.0. We can try to ping Metasploitable on 162 to make sure we have connectivity. We can also try to ping from Metasploitable the Samurai installation on 189. And it appears that we have connectivity back and forth between both machines. So to use Nessus, we're going to go to the Nessus console. So we'll start Firefox, again with the Nessus service already running, and we'll browse to HTTPS, localhost. We're going to use port 8834. So again, note that we're using HTTPS. The Nessus service doesn't offer the console over unencrypted connections. So if you get an error, it may be that the S has not been added onto the protocol. When you installed Nessus, you gave it a username and a password for you to log in with. So you're going to log in with that username and password. We can see an example here of scans that have already been created, and it'll show up under My Scans. You can create scans directly, but it may be more useful to create policies and then scans from those policies. The reason is that you can create a policy that contains the general configuration that you want the scan to run with. But then from that one policy, you can create many scans. That can save you time if you're going to run a lot of different scans, but generally using the same configuration. To create a policy, go to Policies, and then click on New Policies. We'll go ahead and start creating some policies that we can use to do discovery and vulnerability assessment. So we're going to click on New Policy, and then we can start with a host discovery just to find the hosts. The ones with a purple banner are only available in the commercially licensed version of Nessus, but you can use the ones that don't have the banner on them. So we're going to use host discovery to get started, and this one is just going to be a host discovery scan, so we'll just call it host discovery. You can give it a description if you like. Over on the left is where we set up the different configuration. So you'll have the general settings, and you also have the permissions that you can give it, and then the type of discovery that you want to do. So we're just going to do a host enumeration. We can see that this is going to be approximately equivalent to the way Nmap does its ping scanning. There's going to be some TCP and ARP scanning, and then ICMP as well. The other types would be also similar to Nmap in OS identification, the port scans, and then you can set up custom scans. And then you can also set up some configuration about the ports, but we're just going to leave the defaults. So now we have a host discovery test policy that we've created, and from that we can create a new scan. We can also go ahead and set up some other policies as well. So after we do a host discovery and we have the host that we want to target, we may want to see what ports are running on that host. So we'll do host discovery, and then we'll do a port scan. This time we need to change the default type from host enumeration to port scan. You can do common ports, which is going to be somewhere in the neighborhood of 1,000 ports, or you can do all ports, which will scan 65,535 ports. We'll just do common ports for the sake of speed. After we've discovered the hosts and the ports that are running on the host, we might want to feed that information into a vulnerability assessment. So to do that, we would pick the basic network scan. And the settings are over here on the left. So again, it's going to do a port scan to discover common ports. You can also do all ports, which is not necessarily a bad idea if you have a very small number of targets and you're not really sure exactly what the purpose of the different boxes are. Under assessment, you can pick the assessment types, including what kind of web assessments you'd like to do, assuming that Nessus actually finds a website. You can set the report settings and then also set the advanced settings under the settings on the left. And then finally we'll do a basic network scan, but we'll go ahead and give it the credentials to Metasploitable. And one of the things to note when you're trying to do a credentialed assessment is under the new version of Nessus, the credentials are entered by clicking on this link up here. And so the type of credentials we're going to use are going to be the SSH credentials. And the authentication method is going to be username and password. So over on Metasploitable, the username is msfadmin, and the password is the same. That's the root user, so we don't really need to elevate the privileges. Because this is SSH, it's going to be over port 22, and we would have verified that using the port scan that we're going to be doing here in Nessus, or a port scan that we had previously done in Nmat. So now we have our host discovery, port discovery, vulnerability assessment, and authenticated vulnerability assessment. Once you do these scans, you'll notice that there's a big difference between the vulnerability assessment and the authenticated vulnerability assessment as far as the number of items found. That's because when Nessus can log into the host, it can go through the configuration files of the host, especially if it has root permissions, and discover the types of software that are running on the system, the versions, and look up those vulnerabilities in a database. So once you have your policy set up, you can create the scans that match the policies. So you click on New Scan to create a new scan, and then you can use the templates that you created. Notice that there's a User tab that shows up once you create some policies. And then your policies are going to be shown here. So the first one that we did was the host discovery test policy. You can create a folder to put your scans under. We're just going to use the default. And if you have scanners that you're controlling from this console, you can pick the scanner. In this case, we just have the local scanner. We don't have scanners installed throughout. And then you would pick the targets. So we knew from the Metasploitable that the different targets, the target was the IP address of Metasploitable itself, which should be 162. And you can see that again by doing an ifconfig. If you weren't sure what the IP address was of the target, which is common, then you could just scan the subnet and try to find the target. So to put a class C in there, we'll just use the /24. And then the scan runs. You can also schedule the scan to run later, and you can make a scan to where it'll run when you click on run. So you don't have to always have the scan run right away. While that scan is running, we'll go ahead and create another scan. So the second policy that we created was the port discovery. And we're cheating a little bit, but we know that the host discovery scan is going to end up finding host 162, so we'll go ahead and enter that in. If you click on schedule, this is where you can decide if you want to run the scan immediately. You can uncheck this box and save it, and then that'll let you play the port discovery scan when you want to by clicking the launch button. So the host discovery scan has completed. We can click on that, and we'll see that different hosts were discovered. .1, 162, 192, and 254. If we didn't have knowledge that Metasploitable was already on 162, what we could do is we could take these 4 IP addresses and feed them into the next scan. Typically, that's the way it would be done. So if we go over to the port discovery scan, we would enter those in here. So we can launch the port discovery scan by clicking the launch button, what looks like a play button here on the right. So while the port discovery scan is running, we'll go ahead and create the next scan. So we created a vulnerability assessment test policy. We'll use that for the vulnerability assessment scan. And again, cheating a little bit, but we know that eventually it's going to discover that Metasploitable is running on 162. We're going to see that there's a whole lot of ports that are going to be open on that host. And if you go to Rapid7's website, you can see a lot of documentation on Metasploitable, and you'll see what types of services it has running, and that there's approximately 20-25 ports on that box. Again, we'll go to the schedule and uncheck the launch scan immediately. And then that'll go ahead and create the vulnerability assessment scan. These scans are running fairly quickly because we're obviously running on a local network, plus we're not scanning very many targets, but these scans can take some time to do. So we'll see that there's 25 ports that were discovered on host 162. Now, we'll go ahead and start the vulnerability assessment scan. We'll come back and look at the port discovery scan. So on the vulnerability assessment scan, we'll go ahead and launch it. And you can see how the vulnerability assessment scan is doing by clicking on it and looking at the progress bar. If we go back to the port discovery scan, we can look at the results. So it discovered 13 ports on 177, 1 on 176, 1 on 254 respectively, but 26 ports on 162. And technically this is probably 25 ports, because one of the pieces of information was that it responded to the ping that discovered that the host was active on the network. We can click on the port discovery and then see the ports. So we have FTP, SSH, Telnet, email, DNS, web, so on and so forth. And you can go down and look at the various ports. And of course the ports themselves that are open may imply certain issues with the host, but we'll use the vulnerability assessment results to see most of the issues. Now if we go back to the scans, remember this is not an authenticated scan, so the scanner is going to be limited in the type of vulnerabilities that it can find on the host. Let's go ahead and create the last scan while we're waiting for the vulnerability assessment scan to complete. So the vulnerability assessment scan is running, and it's only about 2% complete. It can take a long time for these scans to complete. So when you run them, you may want to allow the scanner to run for 30 minutes to an hour per host if you believe that the hosts have a tremendous amount of problems, or if you're very far away from the host, such as you're scanning from the internet over several different routers. You'll find that type of information out when you do the reconnaissance and the footprinting of the network, usually using tools like Nmap to do a lot of the initial discovery about how the different scans are going to go. To see some of the results, go ahead and click on the bar, and then you'll notice that the results are color-coded. So the criticals are red, orange high, medium for yellow for medium, and then lows. Even some of the low vulnerabilities can be good stepping stones into the next phase of the assessment, which would be the exploitation phase. So clear text FPT credentials, for example, already implies that we may be able to set up some sort of machine in the middle attack, or start guessing against FTP service using a tool like Hydra, since FTP services often don't have any type of lockout controls. So don't ignore the lows just because they are low. They probably don't yield very much results, but that's not necessarily always true. Obviously, we would probably focus in on the criticals at first. Vulnerabilities that are critical tend to be so because there's a publicly known exploit available for them, and they're very easy to exploit, and they typically have a high level of exposure, meaning that the service is easy to reach, easy to interact with. We'll go ahead and take a look at the VNC server password and drill down on that one. So the reason that Nessus is concerned about this particular service is that Nessus was able to log in with a password of password. Because Nessus was actually able to confirm the vulnerability, that raises its ranking as well. If there's a remote exploit available, Nessus will tell you over here on the right hand side. Now, this particular vulnerability doesn't even require an exploit. You can just log in. That's the problem. As the results come in, they'll start to stack up here under this view. You can see that the console will refresh once every 5 or 10 seconds or so. Some of the high vulnerabilities can be pretty serious as well. Some of them won't even require exploits necessarily. For example, the unprivileged access to shares would just let you see the files that were located on this file share. Vulnerabilities like this VS FTPD smiley face backdoor may actually have an exploit associated with them. So if we drill down on this and then look here on the right, we can see under exploit information that exploits are available. And in this case, Metasploit contains a module that would allow you to exploit this vulnerability. So you could take this information and go out to the Rapid7 website to research this module, learn what you need to learn about it, and then you could also practice with it on a virtual machine lab like this that you set up in advance before you try to use it on an assessment. Now, there's one more scan that we haven't run yet, and it would take a very long time, and it would be run very similar to the vulnerability assessment scan, and that's the authenticated network scan. In this case, the scan will take approximately as long as the vulnerability assessment scan, and the results would be similar, except for it's going to find even more vulnerabilities than the vulnerability assessment scan. So after this vulnerability assessment scan completes, you'll want to go ahead and run the authenticated network scan by clicking the launch button to see the differences between the authenticated scan and the unauthenticated scan. And it's important to note that when doing vulnerability assessments, if it's at all possible to do a credentialed scan, whether that be on a web application or on network hosts, always use the credentialed scan after testing that the scan doesn't harm the host, because you'll get much better results than you would normally with the regular vulnerability assessment scan.